Well, thanks very much for your invitation and for your introduction. It's great to be part of the science group U3A once again. This is the structure of the webinar. I'll talk briefly to the challenges we faced and what the current condition is, how my own view is developed, points that I've found notable that I want to mention up front, 6 in all. I'm afraid you're going to have an introduction to operations management basics in the middle of the talk. I'll talk about the work, the application of lean tools within the framework of operations management, which resulted in a newsletter and consequent webinars. Also has led to simulations, resourcing models, and recommendations to the National Department of Health. And then some worries. So the vaccination challenge facing us here in South Africa. We need to inject at least 40 million people at least once, as soon as possible. This is the current situation. This is the world picture. Our first case was the 5th of March last year. The 11th of March last year, the World Health Organization declared COVID-19 a pandemic. On that day, there were 118,000 cases in the world. South Africa had 13 reported cases. There are now over 141 million cases in the world, and South Africa has about 1.5 million cases. I'm sure you're all familiar with this kind of dashboard, which comes out daily, telling us our cumulative cases, cumulative fatalities, mortality rate. So how has my small window view developed? Well, in early January, I saw an article online reporting on a UK mass vaccination site. This led through various steps to offering a webinar to a supply chain organization collaborating with the Lean Institute early in March, and before which I had to scramble to visit 2 vaccination sites to develop some sort of practical understanding. Those insights have been used to develop a resourcing model, which resulted in my being drawn into meetings with the National Department of Health officials planning the rollout. And then finally preparing a recommendation in support of large and mass vaccination sites. So the first notable point I want to make is I've been hugely impressed with the professionalism of a large number of people in South Africa, working tirelessly, long hours, 7 days a week, back-to-back Zoom meetings. And some of those have been involved since before the pandemic started, as they prepared for it. Secondly, it's a very complex challenge. It's technically complex at a strategic level, at a systems level, and situationally at vaccination sites and distribution centers. It's also sociologically complex, the human factors involved for us, members of the public, and for the professionals involved. The good news is that South Africa has experience through the HIV agencies over many years, well-funded, experienced staff across a wide range of medical and social marketing issues. We've also got a number of funding agencies involved. We've developed experience with the PPE distribution over the last year and ongoingly. And then more recently, the Sisonke vaccination campaign, which was the J&J vaccine being applied under research protocol measures for healthcare workers in South Africa. So we've vaccinated nearly 320,000 people up till Friday last week. The fourth point, we will likely, almost certainly, travel a bumpy road to vaccinate over 40 million people. What I'm saying is expect publicity for the bad experiences. Point number 5, the national plan is for around 1,750 vaccination sites, with the goal by September of delivering 300,000 jabs per day. There'll be 50 mass vaccination sites doing about 2,000 jabs a day, so about 1/3 of the total vaccinations. 200 medium to large sites at 300 jabs a day, and 1,500 small sites, 80 jabs a day. On Friday, there was a press report saying we plan to vaccinate 16.5 million people between May and October. Well, that allows one to do a little bit of arithmetic, and that says that's 93,000 jabs per day, working 7 days a week, which causes one to reflect on how will this campaign build up between here and October? Well, if you look at this graph, which is saying vaccinations per day over the coming months, the total of the plan by September is to achieve 300,000 jabs a day. The average, according to the journalist, is 93,000 jabs a day from May to October. What's the shape of the campaign? Will it be the green line, a steadily improving number of vaccinations a day? I think we'll all agree it's not going to be a precipitous arrival at 300,000. Or will we be able to accelerate rapidly up front and taper as we approach 300,000? Or will it be closer and, I think, much more likely, the red curve, a slow start and accelerating from mid-June to mid-July? Unfortunately, of course, mid-June to mid-July may be when we experience the third wave in this country. So here's the basic operations management perspective, for which I must offer some apologies. So I want to introduce you to two matrices. The one is called the efficiency matrix, and the other is called the product process matrix, which I'll start with. So it's a basic view taught in kind of lecture number 1 of ops management, that as we look at the production of different things, in terms of the relative standardization of what we're dealing with and the relative volume of what we're dealing with. With the vaccination program, we're dealing with a highly standardized product being delivered in high volume. That means we want a continuous process operation. To do that, we need to standardize and stabilize the way we deliver vaccinations. And we want to keep things flowing through that process. As my Japanese teacher used to ask me in hospitals or in factories, pointing at a queue, pointing at people waiting, pointing at work in process, standing on pallets, he would say, why for this not moving? We need to keep things flowing to get continuous flow. We need continuous improvement to achieve that. Efficiency matrix takes a completely different perspective. It's a rather neat bit of work by Modig and Ahlstrom from Sweden. So resource efficiency and service efficiency. Resource efficiency for a site would be the actual output of a site, let's say per day, and the rated output, the output for which that site has been resourced. And let's say it was resourced for 2,000 a day and is actually achieving 1,800 a day. That's about an 80% resource efficiency rate. Service efficiency is what you and I experience. So when we arrive at the venue to the time we leave the venue would be the journey time. could be 2 hours, could be 4 hours. The service time is the time it takes to deliver the value for which we came, in our case, the actual injection, which may just be 5 seconds. So you could have a service efficiency of 5 seconds divided by 5 hours. Where we want to be with any process is in the top right-hand corner. Highly efficient use of resources and a very efficient process for the public going through that facility. Warning number 1, and you'll see this come up repeatedly, is that variability from any source damages both resource efficiency and service efficiency. And we don't want to be in the bottom left-hand corner with very inefficient use of resources and a very bad service experience for us, the public. So there is an absolutely primary imperative. We must stabilize. We must stabilize operations. This is an insight from queuing theory, which allows for variability in the way a system operates. And these lines are showing the relationship between capacity utilization, which has to do with resource efficiency, and the waiting time of people in the system. And of course, that's related to service efficiency. If one wants a short waiting time and one has a very stable system, you will get very good resource efficiency. But this is what happens as you have more and more variability. You get lower and lower resource efficiency. So again, we need to stabilize operations in the mass and large sites at least. So we want to be in the top right-hand corner. Management thinking would often say, let's go for resource efficiency first and then serve the public better as we go. But I would recommend that the improvement journey concentrates on stabilizing operations and targeting flow so that we get to the top right-hand corner through good service efficiency and good resource efficiency. So, a summary of what one takes from an operations management perspective. Now, there's a lot here, 8 points, and we will revisit it because it forms the basis of the recommendation. So we need to resource sites in terms of a target rate per day. We need to design the process flow for each site to achieve flow and to avoid batching. We need to deliver good practices. We need to develop standard operating procedures through actual trials with actual operators. We need to work with the folk who will do the actual work at these sites to establish good cycle times. We can use those standard operating procedures to train site operators. We can initiate site operations and introduce a daily management system, which will be to stabilize operations, improve operations towards the rated output, and then hopefully go beyond rated output through further continuous improvement. So where all this started for me was in early January, seeing an article of the UK Mail Online, which was describing a UK mass vaccination sites which had 6 parallel lines. And the article said that they were aiming to do 4 injections per minute. So that's a simple calculation to say, well, each line is operating at doing an injection every 90 seconds. And that for me was a light bulb moment, understanding that absolutely clearly This is an operations management challenge. So I'm afraid you've got to prepare yourselves for a little bit of arithmetic. A core tool in the Lean toolbox is a cadence calculation. It's what is the rhythm at which the system needs to work in order to achieve its target output. So the equation is called a takt time equation. Takt is a German word co-opted by Toyota in Japan, because in German it is a word that refers to rhythm or cadence. And it's a very simple formula. It's working time available divided by customer requirements in that time. So if we take that we want to vaccinate everybody in 3/4 of a year, so in 9 months, 3/4 times 52 weeks, that we're prepared to work 7 days a week, and we will work 8 hours a day, converted into seconds, and the customer requirements are for 2/3 of the population to be vaccinated as we work 7 days a week, 8 hours a day for 9 months. Please note that this equation has nothing to do with resources. It has nothing to do with working hours, man hours, human labor hours. It is simply a measure of how often do we need to do the work in order to achieve the target. So if everybody in South Africa gets the one-shot vaccination, that's the cycle time. That's the takt time. We don't relate to that too well, so I'm going to use the conversion of that. That's about 5 injections per second to achieve 2/3 of the population within 9 months. If everyone gets the Pfizer vaccine, we need to work twice as fast and do 10 injections per second. If we allow for only an 80% use of the 8 hours per day, and we make a further allowance for variability in its operations, the J&J comes in at about 8 jabs a second, and Pfizer at about 16 jabs per second. Well, the question clearly is, how many vaccination lines do we need to achieve such rates if we're able to achieve the 90 seconds per injection referred to in the UK article? Well, it's another little equation. The number of lines needed is the time to give the injection divided by the takt time. So for the Pfizer for the J&J jab, turns out to be around 460 vaccination lines. And if it's Pfizer, it's double that number. If we allow for capacity erosion, it's somewhere between 720 and 1440 vaccination lines. It was with these scribblings that I wrote a newsletter to the about 3,000 people on the Lean Institute Africa's database on the 19th of January. It was called A Call to Arms. The main points I made, or the main point I made, was that we need people with process design and process improvement skills to help set up the sites, to help stabilize the sites, and to support continuous improvement at the sites. So the outcome of this newsletter was my being approached and agreeing to do 2 webinars. The dates were set on as the 3rd of March and the 3rd of May. The 3rd of March turned out to be just 12 days after the vaccination of our healthcare workers started. That campaign worked under a Johnson & Johnson clinical trial protocol, which has been called the Sisonke process. So with the first seminar coming up, my colleague Samantha Allen, the Lean Institute CEO, and I scrambled to go to see the Groote Hospital and Tygerberg Hospital vaccination centers. This is Sam's rough sketch of what we saw at Tygerberg. This is everything neatened up to show you that there was a pharmacy process to fill and label syringes, a vaccinee journey where the ID was taken, a script was developed, it had to be matched to a syringe. The person and the syringe went through an administrative process called EVDS, and finally to the injection, then to an observation area where people have to wait for at least 15 minutes to see if there's any adverse reaction, and then exiting. So comparing those two sites in late February, Groote Hospital, the bottleneck was filling the syringes in the pharmacy, which happened to be on the first floor of Groote Hospital when the syringes were actually being used in the parking lot in a different building. Groote was using 6 people. Each was able to fill 10 syringes per hour. So the limiting factor for the Groote site was 60 vaccinations an hour. They had 18 delivery points with 2 people at each vaccination point. So in fact, because of the imbalance between syringe filling and syringes being used to inject people, each of those delivery points could take 20 minutes. So in total, they were using 42 people to achieve 60 vaccinations per hour. Tygerberg was filling syringes with 2 people, each of whom were doing better than 40 per hour. So they were achieving a vaccination rate of 80 per hour. They had 11 delivery points, which were working at 6 to 9 minutes per jab. So this was nicely balanced between syringe filling and injections. So they were could do around 80 per hour with 24 direct workers, Groote 60 per hour with 42 direct workers. Just, I want to draw your attention to bottleneck is not a bad word. There is always a bottleneck in any process. It's very important to know it and to know where it is because it determines the output rate at any particular time and needs to be matched to the tact time and the cadence required. So the seminar happened on the 3rd of March. We were very privileged to have these 3 people and these 2 people, Jenny Coetzee and Minja Milanovic, participating. Annelies Bezuidenhout is the Groote Hospital Finance Director. She was heavily involved in making sure that the resources were available. There was internet access needed for the EVDS system at the site at Groote. Garth Hankey, Process Improvement Coordinator at Groote, was involved in the training and setting up. Associate Professor Catherine Orrell was involved in running the Groote Vaccination Center. And we were joined for the discussion by Dr. Jenny Coetzee and Minja Milanovic, both involved with the Africa Potential Foundation, with many years' experience, particularly in the HIV scientific programs and rollouts of medication. So what were the insights from the webinar? Well, we learned that the sites had just 10 days to set up, and they had to make do with what they had. So here is the view from the main building down onto the parking lot, parking building at Groote. Long journey from the first floor in the old building down through along an elevator, through the front door of first gear, all on a little trolley with 60 syringes, delivered about a 300 or 400 meter journey. Contrast that with Tygerberg, where the syringes were being filled in this room and the injections were being given in the adjacent room. They had to work with what they had. These are pictures from the Tygerberg site. This is in the pharmacy area, the refrigeration for the batches for the day. Here are 5 batches being thawed, 5 vials per batch. Here are the 5 vials. Each vial is suitable for 2 syringes. And then finally, those syringes delivered to the vaccination area. The EVDS system, we learned from the webinar, was pivotal to operations, but there were troubles with it. You and I have either already, or we will soon also interface with the EVDS system to register. So further insights, huge variations amongst sites around South Africa and indiscipline amongst those coming to be vaccinated, including at times a troublesome trade union. So people were trying to jump the queue, people were arriving at a vaccination center without a voucher, they were not arriving according to the schedule they were asked to comply with, or they were not arriving at all. And because thawed doses have a limited time, there would then be a mad rush to find people for whom those doses could be used. So following the 3rd of March webinar, Sam and I were drawn into Zoom calls with a growing circle of people with responsibilities for the national rollout. Jenny and Minja continued to collect data on cycle times at various sites around South Africa and administrative differences amongst sites. Sam and I worked on clarifying the process flow currently and the future state flows and developing resourcing models. The bottom line of those discussions, well, even within the same site, doing the same process, for instance, the EVDS system, observers were reporting anything from 1 minute to 15 minutes for the same process. And then there were also huge variations between sites. So arising from this realization that there was no consistent standardized way of doing anything, and the cycle times observed were unsound for planning processes. So big conclusion number 1. This red writing is really important. We need to do physical simulations to identify standard operating procedures so that we have predictable and efficient cycle times, that we can match resources to those required cycle times. We can use those standard operating procedures to train staff. They become the basis for stabilizing operations and the basis for improving operations. So, what kind of resources do we need? So using the Sisonke process flow with the cycle times at each stage, here's the script, filling the syringe, matching the label, the long EVDS cycle. What do we find? Well, the Sisonke process would need 7 people for script writing, 7 people filling syringes, 5 people for matching the person and the script and the syringe, 25 people to man the EVDS system, and 10 people giving injections, if we were to achieve 2,000 jabs per 8-hour day. But the coming rollout protocol is very different from the Sisonke protocol. The big difference is here. So here is the flow of syringes, etc., into the vaccination area. Here is the flow of people through a screening process into the vaccination area. Here, the person giving the injection has to do the administration, all of these steps. So for a 2,000 jab, 8-hour operation, we would need the same number of people, but now just 7 people to do screening, but 46 people to do the EVDS and jab. So comparing those two, if we had a bottleneck equivalent to 90 seconds at the jab point, we would need 10, let's call them nurses, versus 43 in the proposed protocol for phase 2. So the UK mass site, the bottlenecks per line, 90 seconds. It looks as if we're headed for 438 seconds, nearly 5 times longer. Why? Because the person giving the injection is required to take the vaccinee through all the admin protocols. The practical outcome is we need more skilled people, we need more nurses, we need more people to do the injection, although the total number of people remains the same. So what's the consequence? This is the national plan, number of sites, mass, large, small, total, target by September. Well, if we can achieve 90 seconds, we need 500 nurses. If we stick with the protocol as I now understand it, it's a lot more. And we're just looking at the mass vaccination sites here. So what might the venues look like? These are photographs from all over the world. This one here is a mass vaccination site in Scotland. This is one in America, which is a drive-through facility. It's interesting that several sites in America are for the elderly, using either drive-through facilities or a facility where you take a seat and the administration and screening and vaccination individuals come and serve you so that you don't have to stand endlessly in a queue inching forward towards the chair where you will receive your injection. So Dion de Grucci, who works through an agency funded by USAID, has developed these visuals of what our sites might look like. So this is a two-vaccinator site, proper spacing of people waiting, and this is the post-vaccination observation area. If we look at a site able to do about 2,000 jabs a day, it'll need 50 vaccination points, and it'll look something like this. So what do we recommend? What I have here is very similar to what I showed you before. We need upskilled people to do the resourcing for each site based on a target jabs per day. We need to design the process flow to ensure that there is flow and we avoid batching. We need to run actual trials with the people who are likely to work, obviously a subset of the people who are likely to work at these centers, to establish standard operating procedures, which we can use to train the operators, We can use those to initiate the operations and to implement a daily management system, which day by day will work to stabilize operations and improve operations towards greater efficiency. And ultimately, we will want people to continue improving above the rated output. So De Gruchy and others are working at this level. I'm not aware of who is working at this level, but we have put in a proposal to that effect. But what we're talking about is a set of actions coming straight out of the operations management playbook. Some sundry worries. We are dealing with complex supply chains. I've been talking mostly about the vaccination sites themselves, but here is a statement last week from a professor of operations management at McGill University in Toronto. Just gives you some sense of the complexity, the volumes involved. Every box of vaccines requires roughly 8 to 10 boxes of accessories like vials, syringes, dry ice, and freezers. The Pfizer vaccine, which in South Africa will be mostly used for concentrated urban areas because it needs to be maintained at minus 70 degrees Celsius. And the J&J vaccine needing less severe cold chain protection will be used for rural areas. But this is another reason why I keep stressing the need for stability. Imagine how easy the restocking of 50 sites would be, the mass vaccination sites would be, if day after day they achieved exactly 2,000 jabs. We would just replenish them with 2,000 new doses per day, 200 vials per day for 2,000 jabs per day. However, if those 50 sites are unpredictable, each one fluctuating on consecutive days and over a week, somewhere between 1,500 a day and 2,500 a day, the resupplying becomes a much more complex task. So further worries. I have real worries about the behavior of the public, the need to schedule individuals after they've registered to be vaccinated, the schedule compliance that people demonstrate. Will they arrive early? Will they arrive late? Will they not come at all? I'm concerned that the default behavior of the public in the public health system is to go early. And if you've got 2,000 people arriving between 7 a.m. and 9 a.m., you're going to have bunching at the vaccination sites, setting up hotspot potential, people needing seats, people wanting water, people needing toilets. This scheduling and schedule compliance is going to be a very difficult nut to crack. I'm concerned about site preparation and site maintenance. This is going to go on for months and months and months. Those sites need to operate well and reliably and stably. I'm concerned that we need to have a daily management system at each site. That needs to be thought through. People need to be trained to work with it to improve their own operations. And of course, I'm concerned that current predictions are that the third wave of COVID-19 in this country will coincide with our getting the mass vaccination process going. And that third wave will pull nurses back from the vaccination sites back into the hospitals. My biggest worry, taking an operations management perspective, is around instability and inefficiency. Unstable mass sites will result in extra resourcing costs, which sometimes nevertheless will result in overworked staff and also idle staff as things fluctuate. There are huge implications of instability for the replenishment supply chain, for the way public transport delivers people to those sites, and the implications for public confidence as the experience of individuals is disseminated amongst friends. Secondly, the consequences of inefficiency is that the staff working there will work overtime to try to compensate, to catch up. It's just not sustainable. And staff will become demoralized. They'll feel they're always playing catch up. So I want to remind you of the efficiency matrix, the need to improve via stabilizing and getting flow. If we want good resource efficiency and good service times, we need stable operations. But my biggest worry is inefficiency will result in a delaying of our achieving herd immunity. It'll just take us so much longer to get there. The result will be a further overburdening of the healthcare system, a further exhausting of healthcare professionals, the prolonging of suffering of the people in this country, and still more deaths, and economic damage, tourism sector, entertainment sector, employment prospects for the poor, the tax base eroded. My biggest worry is inefficiency in the system, delaying the achievement of herd immunity. So we will travel a bumpy road to vaccinate over 40 million people. But we'll surely get there. Thank you. I think we must now think about what questions might have come through. Ken, over to you.
Thank you very much, Norman. Can you hear me?
Yes, I can. You're a little bit faint, but I can hear you.
Okay. I'll put my microphone on. There are no questions in the chat room, in the chat box. Could I just kick off a question, Norman, to get the ball rolling? How would you recommend that you do an actual vaccination trial run? What people or vaccinees, as you call them, would be used? Would you go to a large, would you get a large organization to supply you to offer and volunteer those of their staff who wanted to get vaccinated to test out a site, those that could be released from the operations of that company, so that you actually have sort of a couple of hundred people going through the vaccination in the trial?
Ken, ideally one would want to do that, but I don't think we need to get that complicated. We could simply simulate this with some professionals, some nurses, people who know how to operate the EVDS system. We could use fake vials to be filled with syringes. The person pretending to be the vaccinee could hold an orange against their arm, and the nurse can stick the needle into that. I don't think it's a complicated issue. And I know that Sisonke vaccination sites set up by Mediclinic, for instance, have used very carefully thought out processes using industrial engineers employed by Mediclinic. They employ many industrial engineers. They too have a very high interest in good resource efficiency and good service efficiency in the running of their hospitals. So they've applied that to the Sisonke process. Hopefully they are informing others in the national rollout planning, but it doesn't need to be a complicated issue. I think we should be running such trials in maybe 3 centers in South Africa, maybe Cape Town, maybe Johannesburg, maybe in Durban, so that we learn in different settings with different people, and we get some kind of consensus about the best way to do these things.
Okay, the questions are coming in now. The next one is, have the observations of Groote Schuur versus Tygerberg hospitals led to any improvement at Groote Schuur since?
I'm afraid I don't know. I know that the biggest problem in the vaccination in the Sisonke program has been the supply of the vials from J&J.
Okay,
a complication with that has been that the vials are the clinical trial vials that contain only 2 doses, and that makes it trickier to fill the vials, to fill the syringes. No, I'm afraid we got involved a little bit in talking to Tygerberg about setting up a mass vaccination site there, but despite our offering unpaid assistance, I think they were just too busy to even take us up on our offer.
Okay, the next question from Mike and Jenny is, why is the injector a qualified nurse doing the admin?
I wish I knew.
All right, shall we move on?
Well, my guess, what I'm told, is that there needs to be absolutely no uncertainty around which person got which injection from which person, and that the person who gave the injection personally explained to the individual what they were in for, what the potential side effects would be, and got their permission. Why we're doing that in South Africa, I don't know. Clearly, they're not doing that in the UK. They simply would not be able to get an injection every 90 seconds.
Thanks. The next question is from John. Is it expected that there will be political interference?
Heaven forbid.
You can pass on questions.
I haven't even thought of that one.
Okay. Noel Beckers asks, who's responsible for the evaluation of the vaccination process with respect to efficiency/effectiveness?
Yeah, I have no direct insight on that. That's my small window view. But I would guess that Glenda Gray and people in the Medical Research Council, researchers coming through the HIV agencies like the Desmond Tutu Foundation at Groote Schuur Hospital, Linda Gale Becker involved there, will be absolutely following this, and the statistics will be kept. This is such an important thing, such an important thing.
Betty Davidovitz thanks you for an excellent lecture and suggests that you design a presentation to be aired on TV in several languages so that members of the public realize how important it is to arrive at the correct time to avoid bunching and the wasting of precious vaccines.
Yeah, thank you. I think that's the social marketing. social marketing is marketing social services, getting people to go for the vaccination, communicating why and how, and just motivating people to do a socially good thing. Yeah.
Mike and Jenny ask, is duplication a problem? For example, personally registering, but then a care facility undertakes to arrange vaccination for the same person. So say someone's living in a frail care facility, and you got the gist of the question.
Yeah, yeah. My understanding is that that's why the EVDS system is so important, because the EVDS system will have your ID number. And when you come to be vaccinated, that ID number will be checked. And so that ID number will get only one injection if it's J&J, or a second dose if it's Pfizer. But I don't think there's going to be any chance of a person being able to register twice and get vaccinated twice. Of course, if Eskom's electricity takes down the internet and the EVDS system is not operating, who knows what might happen then.
Alan Caulfield thanks you for an informative talk, as does Jeannie Areb. And Alan asks, would it be an idea to get the private sector involved in the logistics for those companies that are involved in just-in-time supply to the motor industry? Alan is aware of that.
Yeah, again, it's my small view, but every now and again I get a glimpse that these professional supply chain people are very involved in those supply chain issues. It's been, it was my point number one. There are so many highly professional, highly skilled people working long hours to address each aspect of this campaign. The private sector is very involved. I was told at one point that Discovery had assigned some of their top actuaries to the process. I've talked about the Medicare people involved with their industrial engineers. There'll be private sector sites and public sector sites. There are a lot of skilled people involved. My concern has been at the situational level to stabilize, because it's got consequences for efficiency, and the delay of the rollout might be a dangerous consequence of getting inefficiency wrong.
Thanks for that, Norman. I'm just checking one more question. No more questions in